Hey everyone, welcome back to my channel, and today we're going to talk about the ERC20 token. The ERC20 token is a token built on Ethereum, and it basically allows you to create an alternate form of currency, an alternate token on top of Ethereum that you can use Ether to do all kinds of cool things with. It's basically a smart contract, so today we're going to kind of dive deep into that smart contract, look at all the functions, look at the data available, and I'll talk about why these functions are there and what you can do with them. So let's check it out. All right, folks, so today we're going to talk about the ERC20 token, and first things first, I'm going to go into some of the projects that use the ERC20 token and maybe give you an idea of what kind of projects you can make and you could launch your own token for. So just checking out Etherscan. If you don't know about Etherscan, it's a block explorer for Ethereum, really great. At the top we got Binance. Binance is an exchange. They did ICO, and a lot of ERC20 tokens are used for ICOs, where you basically crowd sale your token, and then the token does something on the platform later. In this case, the Binance token allows you to get reduced fees on their exchange, so they use this ERC20 token as a way to transfer the right to have these reduced fees and create a market for the different features that Binance gives to its users who hold the ERC20 BNB token. So very cool. We also have VeChain here. VeChain is a supply chain, Internet of Things type of token. Omise Go, 0x, a decentralized exchange. MakerDAO. Maker is a DAO that has a stable coin. Stable coin is a coin that's supposed to keep a certain value and not go too high or too low beyond that. It's been tried many times. Probably the most popular and successful one right now is Tether. I won't go into Tether in this video, but it is what it is. You can read all about Tether and decide for yourself what you think about it. What else do we have? ZIL, Zilliqa, ICX, Eternity, BAT, Basic Attention Token, Augur Rep, Golem, Status Network. Status is a great project. Anyway, a lot of these are just because they did ICOs, right? Oh, Decentraland. This is kind of a cool one. It's like this 3D virtual world, and then you use their ERC20 tokens to buy property within the virtual world. So it's kind of like Second Life and their Linden dollars, but they have their own token called Mana. So anyway, here's just an example of some of the projects that use ERC20 tokens. Oh, one other one, Funfair, decentralized gambling. That's a very cool use case, actually. Like a gaming token in a casino, right? They have their own currency that you use in their virtual casino. Anyway, so let's check out the standard itself and see what kind of data is available and see what you can do with it. So I'm here on the Ethereum wiki. And first of all, ERC, what does it stand for? I believe it's Ethereum Request for Comments. So basically people put out these proposals for different standards for smart contracts and second layer solutions and all kind of stuff like that. And they get a number and they post them to, I think, GitHub or the wiki or something like that. And people in the community can go and they can give feedback, you know, give some comments on what they think about this proposal. And it's just a good way to, it's an easy way to refer to certain protocols, certain smart contracts and things like that in just a quick way so everyone knows what everyone's talking about. And so ERC20 here is a standard, and basically is a standard to create the kind of alternative token that lives on top of Ethereum. So it's not Ether, it's its own thing. But you actually have to use Ether to like move it around and do different things with it, like you do anything on the Ethereum network that involves a smart contract. Well, maybe not everything, but anytime you want to send a transaction, right? So let's take a quick look here at the ERC20 interface. We've got the total supply here, which gives you an idea of how many coins are in existence. Balance of, and it has a argument address token owner. So this tells you how many ERC20 tokens are, you know, owned by a certain address here. Of course, these are both public, and they return integer, in this case the balance. Got this function allowance, and it returns an integer remaining. I'll talk more about this, but it basically is how much an address is allowed to spend of your tokens on behalf of another address. Why would you want to do that? We'll get into that in a moment. It's very important though. Here we've got a very straightforward function, transfer. Transfer allows you to send the tokens to another address. Here we've got a function, approve. And this goes back to the allowance thing. We approve another address to spend a certain amount of our tokens. And then transfer from, we will transfer tokens from this address to another address. And how many tokens? Well, that seems like you could just transfer anybody's tokens, right? Well, that's actually not the case. It has some logic in it that makes sure that you are allowed the amount here in this allowance function, that many tokens in order to transfer. So first thing you do is you approve the tokens. That gives another address an allowance, and that address can transfer from that allowance to another address. It's a little complicated. Why would you need all this? We'll get into that in a moment. And then we've got two events that just record the transfers and the approvals. Also some information here, we've got a token name, we've got the symbol, and that's important if you want to trade this token on decentralized exchanges, and we've got the number of decimal places. So let's take a look here at the source code for an ERC20 token. This is a partial source code. There are many different implementations of the ERC20 token. It can be kind of controversial. As long as these couple functions are there, it's an ERC20 token. It can have additional functions, but it really shouldn't have any less functions than what we review in this video. So we've got the balances. How much tokens are owned by each account? Very straightforward, just declared as a mapping. Here we've got a little bit more of a complicated mapping. This is how many tokens are allowed to be spent on behalf of another user. So we've got a mapping of the owner to a mapping of the person who's allowed to spend those tokens on behalf of the owner and how many tokens. And that's called allowed. Very simple. Here we have a getter for the balances that just returns how many tokens are owned by that address. Next, we've got the transfer function. So the first thing we do is we subtract using safe math. That makes sure that we don't underflow, right? We don't subtract more tokens than we have, etc. So first thing we do, we subtract a certain amount of tokens from their balance in the balances ledger. Then we use safe math again. Notice we're not using the plus and minus signs because they can be quite dangerous to use. I've done a video about that. Go check out the channel on Solidity testing with safe math. Then we add the tokens to the balance of the person we're sending them to, and then we generate our transfer event, and then we return true so that the function that called this function, if that is a thing, if that's what we're doing here, knows that it succeeded, knows that the amount of tokens were there, they were good to be used, they actually had the tokens, and that the person we're sending the tokens to doesn't now own too many tokens, I guess. There's not too many issues that can happen with add here, but that's fine. All right, transfer from, let's just check out the comments here. Send tokens, amount of tokens, from address from to address to. The transfer from method is used for a withdrawal workflow, allowing contracts to send tokens on your behalf, for example, to deposit to a contract address and or to charge fees in subcurrencies. The command should fail unless the from account has deliberately authorized the sender of the message via some mechanism. That's the approval mechanism that we'll see below. We propose these standardized APIs, blah, blah, blah. So the transfer from, like I said, it goes from an address to an address with a certain amount of tokens. The first thing we do, we subtract the balances from the person we're sending, and then we subtract the number of tokens that are allowed to the user who called this function. So notice that message.sender here, we're not subtracting the balance of message.sender. Message.sender might not even have a balance. We're transferring the balance that came from the person who approved this transfer. And when someone approves a transfer for another user, that adds tokens to, and we'll see down here, it adds tokens to the balance, excuse me, it doesn't add tokens because there's some security risks in terms of adding tokens, subtracting tokens from an allowance. You'll see other ERC20 token contracts will actually have the ability to add and subtract from an allowance, but it requires some specialized logic to make sure that you're not generating tokens out of thin air or spending tokens that you're not actually allowed to. So anyway, we subtract the tokens from the person who's allowed to spend them rather than, we subtract it from their allowance, not their actual ledger, not the actual balance, but this allowance mapping that we talked about earlier. And so we subtract there, again, using safe math. And then we just do an add, because we're just transferring to another user, and we record it as a transfer and return true. And finally, the approval process, like I said before, we actually don't subtract any tokens. You still own the tokens when you allow someone else to spend them. We just mark that someone else is allowed to spend this many tokens on our behalf, and then we generate the approval event. So why would you want to do something like this? In Ethereum smart contracts, you will have what's called a payable function. And this is a really convenient way. So when someone sends Ethereum to your smart contract, it does something, right? So you pay the smart contract and it performs some calculation. It makes some change to the state of the variables in the smart contract. It calls other smart contracts. It gives you tokens, whatever it's doing, right? When you want to do that with an ERC20 token, you can't use the built-in payable functionality that exists within the Ethereum virtual machine. You have to come up with your own way to trigger actions when tokens are sent to a smart contract. There's not a super easy way to do that in one step. So what they've come up with here in the ERC20 contract is I will allow the smart contract to spend tokens on my behalf. And so I'll call this function approve, and I'll set the spender address to the smart contract that I want to pay. And I'll set the token amount here to the amount that I want to pay. And once I do that, I can call a separate function, like a deposit function, not something that's built into the ERC20 contract. This is a separate smart contract that we're paying. But let's say it has a deposit function. I'll call the deposit function, and in that deposit function, the first thing it's going to do is it's going to call transfer from to transfer to itself those ERC20 tokens that I allowed it to spend when I called the approval function. And then it can verify that that did indeed work and that it did return true, and then it can do whatever else it needs to do, whether it issue new tokens, whether it takes some action on the blockchain, whether it call another smart contract. But it knows that it has been paid in ERC20 tokens because first thing I did was I approved the smart contract to spend them, and then I call a deposit function, which inside that deposit function on that smart contract, it will call transfer from and transfer to itself the tokens I approved it to be spent. So by doing this, we basically create our own payable type function within the smart contract that instead of using Ether, lets us use ERC20 tokens. So that's a really convenient way. That's why this transfer from exists. There's probably other uses for it as well, but I think this is maybe the most common use so that you can pay a smart contract in tokens or transfer custody of tokens to a smart contract or to another user or whatever, kind of in a trustless way. So anyway, that kind of sums up the ERC20 token standard. If you are a smart contract developer and you use Solidity, first of all, you're going to want to check out all my other videos. Give me a subscribe, give me a like. I've got all kinds of videos on programming smart contracts with Solidity, using cool frameworks like Embark, etc., etc. But secondly, you're going to be interacting with these ERC20 smart contracts a lot. So, study up on them, read about their limitations, read about their flaws, read about where they came from, where they're going. There's all kinds of new improvements on top of ERC20 that have different numbers that you can check out. There's all kinds of changes. For example, tokens that are unique and non-fungible, like collectibles, tokens that don't have decimal points, etc., etc. There's all kinds of tweaks and stuff like that to the ERC20 contract that you can check out. But if you understand these 4 functions, balance of, transfer, transfer from, and approve, you're going to be able to interact with basically any of them and build all kinds of cool dapps that support all kinds of cool tokens. So that wraps it up for this video. Like I said, check out my other videos, and thanks for watching. Alright everyone, thanks for watching. If you found this video useful, please give me a like and a subscribe. That will help other people like you to be able to find this video and get the information they need. Once again, thanks for watching, and I'll see you next time.